Hey everyone, and welcome. Have you ever felt like just getting your app running in the cloud involves way too much heavy lifting? You know, all that server management and setup? Well, if that sounds familiar, you are in for a treat. Today, we're going to dive into a really big shift in how we build and run software in Azure, moving to something way faster, much lighter, and a whole lot more efficient. So let's just start with a really fundamental question. When you think about it, how do you actually run your applications in the cloud? If you're like most of us, for a very, very long time, there's been one main go-to answer. And yeah, that answer has always been the virtual machine. I mean, VMs have been the absolute bedrock of cloud computing for years. They give you an entire server at your command, which is incredibly powerful, right? But all that power comes with some serious baggage. It's a heavy-duty solution. But what if you could get all that power, all that isolation that a VM gives you, but without having to lug around an entire operating system for every single application? What if you could just ship your code and only the stuff it needs to run, and that's it? Well, that's exactly what we're going to unpack today. First things first, let's get into why that classic VM model, as great as it is, isn't always the perfect tool for the job. And really, it all comes down to two things: overhead and responsibility. This picture really tells the whole story. When you use a virtual machine, you're not just running your app. You're also basically a part-time system administrator. You own everything from the operating system up. We're talking security patching, running antivirus, managing backups. You have to do all of that before you can even start thinking about your actual code. That right there is the overhead problem. So how do we get rid of all that overhead and just get back to focusing on our code? The answer is a piece of tech that has totally changed the game: containers. Okay, if you only remember one thing from this, make it this quote. It's so important. A virtual machine virtualizes the physical hardware. It pretends to be a whole new computer. But a container does something way smarter. It virtualizes the operating system. It just carves out a little isolated space on the existing OS for your app to run. It's a fundamentally different and way more efficient approach. And this diagram shows you exactly what I mean. Look at the VM stack on the left. See how every single app has its own complete guest operating system? All that repetition managed by something called a hypervisor. Now look at the container stack on the right. See what's missing? That entire guest OS layer is just gone. All the containers share the one host OS. That is the secret sauce. That's why they are so much lighter and faster. And this super lean architecture leads to some incredible benefits. Since there's no operating system to boot up, containers can start in seconds, not minutes. They are so lightweight and portable. The exact same container will run on your laptop, on a test server, and in the cloud, which finally solves that age-old, well, it works on my machine problem. And all this efficiency means you can cram way more apps onto the same hardware, which of course saves you money. Okay, so we're all on board. Containers are great. We get it. But how do we actually run them in Azure? Well, let's start with the absolute simplest, most direct way to get going. So before we can run a container, we need a place to keep its blueprint. That's called the container image. In Azure, that place is the Azure Container Registry, or ACR. The easiest way to think about it is like a private GitHub, but for your Docker images. You build your app, you push the image to ACR, and from there you can deploy it pretty much anywhere. This is always your first step. All right, once your image is tucked away safely in your registry, the absolute fastest way to bring it to life is with Azure Container Instances, or ACI. ACI does one thing, and it does it perfectly. It runs a container for you. That's it. No servers to manage, no complex setup. You just point it at your image and poof, it's running. It really is the easy button for containers. So when would you actually use ACI? Well, it's perfect for simple, isolated jobs. You know, like a batch job that needs to process some data and then shut down, or a quick dev environment to test a new feature. It's also great for bursting, which is just a fancy way of saying you can quickly add extra power to a bigger system when you get a sudden spike in traffic. Now, ACI is fantastic for single containers, but modern applications, they're usually not that simple. They're often built as a whole collection of smaller services, microservices, that all need to talk to each other, scale up and down independently. For that kind of complex world, we need something a bit more powerful. And this really is the million-dollar question in modern cloud development, isn't it? How do you manage that complex web of different services? You've got containers that need to find each other on the network. You need them to scale up when traffic hits and scale down when it's quiet. You need to roll out updates without taking the whole thing down. Trying to juggle all that by hand would be an absolute nightmare.
And the answer to that nightmare in Azure is a service called Container Apps. It is a fully managed serverless platform built precisely for this microservices problem. And the key phrase to lock onto there is fully managed. Container Apps takes care of all that complex behind-the-scenes work, the orchestration. So you can just focus on writing code, not wrestling with infrastructure.
So what's actually under the hood here? Well, Container Apps is built on the power of Kubernetes, which is the industry standard for managing containers. But here's the beautiful part. You get all that power without ever having to manage a complex Kubernetes cluster yourself. It's also serverless, which means you only pay for what you use, and it can even scale down to 0, saving you money. It handles things like automatic scaling, service discovery, and smart traffic routing, all right out of the box. So we've looked at 2 really powerful but different ways to run containers in Azure. Now let's put them side by side to make the choice between them crystal clear.
This chart really nails it. Think of ACI as your go-to for single fire-and-forget tasks. Need to run a quick script to process some data? ACI is your guy. But when you're building a complete application with multiple moving parts, like a web app with an API and a background service, that's when you're going to want the power of Container Apps. It's really the difference between a simple, single-purpose tool and a full-featured workshop. ACI is for simple execution, Container Apps is for managed scale.
So the decision really does come back to you and what you're trying to accomplish. Are you just launching a single container to do one quick thing? Or are you architecting a whole complex system of services that need to work together? At the end of the day, there is no single best way to run containers in Azure. There's only the right tool for your job. Azure gives you a whole spectrum of options, from the simple hammer that is ACI for straightforward tasks, to this sophisticated powered toolbox of container apps for building an entire house. So the real question isn't which one is better, it's what are you building next?